My name is Simon Thomas, Assistant Professor in the Department of Information Technology, Kongunadu College of Engineering and Technology, Trichy. In this lecture, we are going to discuss about AVL tree. AVL stands for Adelson, Welskill and Landis. These three peoples combined together and produced this AVL tree. This AVL tree is a binary search tree. So, binary search tree means the right child value is less than the root node and the left child value is greater than the root node. This is the properties of binary search tree, and this AVL tree should follow this property, that is binary search tree. And the AVL tree, here we are going to calculate the balance factor of each and every node. The balance factor value must be 0, 1 and minus 1. If the value is not 0, 1 and minus 1, then we have to perform rotation operation. The balance factor will be calculated by using a formula, that is BF is equal to height of left subtree minus height of right subtree. Hence, the height will be calculated by using some set of functions. Here, the height is the longest path from leaf to root node. Okay, for example, here consider a tree. Okay, consider this tree. Here, the height of this tree is, we have to find the longest path from leaf to root. Here the leaf value is 0, the height of leaf is 0 and the next level will be 1 and that before level will be 2. So the height, similarly from this way, the height will be 0 and here 1. So this path will give 2 and this path will give 1. In this, we have to choose the longest path. Here 2 is the value. So the given tree height is true, 2. So as I said earlier, the balance factor value must be 0, 1 and minus 1. If not 0, 1 and minus 1 means, then we have to perform rotation operation. Here we have two types of rotation. One is single rotation, another one is double rotation. And one more thing, suppose if the node does not contain any left child or any right child means, we have to take the value as minus 1. Okay, for example, this node, it does not has left child. So the left child height is, we have to take minus 1. Similarly, for this right child, it is present, then no issue. So we have to take the height as 0. Similarly, for this node, the left is not present and the right child is also not present. So that we have to take the value as minus 1 and here also we have to take the value as minus 1. Okay, let's discuss one small example. Consider a tree. 10 is the root. Here 5. Here 8. Here 1. So whatever the node we are creating, here we have to check the properties of binary search tree. And here we have 15. See, consider this tree. In this tree, we are going to calculate the balance factor. So when we are calculating the balance factor, we have to come across with the leaf, then the next level, then the second level, like that we have to move. So here I am calculating the balance factor. So as I said earlier, if the node does not contain left child means the value is minus 1. So minus 1 and the formula contain 1 minus, so minus, and the right child value is also minus 1 because it does not contain right child. Now we are solving this. So minus 1 minus into minus plus 1, it will give 0. Okay, or else or else we can say that the value of if the node does not contain any left child or right child means we can take it as 0. Similarly, this one is 0. Similarly, for this node, BF is equal to height of left subtree. So it contains only one child, and the value is 0 minus here the value is right subtree contain one node, so the value is 0, height is 0. So 0 minus 0 is 0. Similarly, for this node, it does not contain any left child and right child, so we can take BF is equal to 0. For this node, BF is equal to height of left subtree. So this path, this is 0, this is 1, and this is 2. Okay, so we are calculating BF for this node, so we are not including this. So this is 0 and this is 1. So 1 minus, from this path also we are getting the same value, that's why I took 1. From this node, the height of right subtree is 0. Here this is 1. And we will discuss the rotation operation. So as I said earlier, it contains two types of rotation. One is single rotation, another one is double rotation. A single rotation is performed in two cases. One is an insertion into left subtree of left child. Another case is an insertion into right subtree of right child. Similarly, we have one more rotation operation, that is double rotation. So double rotation is also performed with the help of two cases. One is an insertion into left subtree of right child, and another case is an insertion into right subtree of left child. Okay, by performing this, we can violate the tree, that is we can balance the AVL tree. That's it. Thank you.